Continuing on here in our AZ-801 series of videos is my least favorite subject, and that's going to be failover clusters. Um, least excited or least favorite subject probably because these can be the most difficult things to implement. It can be really tedious going through the trouble of setting everything up and getting it working. And in reality, the larger a business gets, the smaller the use case becomes for clusters because they're designed to be, a server high availability solution. But as you get to be a bigger and bigger organization, there's tools that definitely replace a lot of the functions of failover clusters and do the jobs better. So we're going to be covering some stuff here. I'll get right into our overview here. We're going to go over, kind of what I was just talking about. What exactly clusters are used for from the high availability standpoint. I get to use my brand new whiteboard, which we'll cut over to in a second. Got my new office space here, so I'm actually kind of excited just to use it. And then we're going to get into some other topics about it. We're going to go over the process of actually creating a cluster from start to finish and what that looks like. I'll also walk through kind of the cheesy hacks that I'm doing to provision the elements that I need in Azure, because as a side note, clusters in Azure are not really a thing. So I've had to jump through some hoops to get everything working. So we'll go through the different process of creating a cluster, and then last step, after we've created one, I'm going to walk through the different elements that are involved in a cluster, kind of what we're seeing and what the different components are that make it up. And then we'll spend some time definitely talking about quorums, because that concept, if you're studying for the AZ-801, it's good to just understand what that's doing and what your options are there, though once it's set up, you never have to think about it. So I've kind of gotten to the habit, I've realized, of making separate intro videos for each one of these subjects I'm doing, and the intro videos are short and not really useful because they're not actually going to go into the topics. So rather than separate this sort of content overview into a separate video, I'm just going to go straight into it and hopefully make the videos a little bit more natural feeling. So with that being said, let's cut over to my new whiteboard and make sure this works. So here we go. All right, I got my new space here, my new whiteboard. So I can write things and not have to use Paint, which I'm very excited about, because using Paint on a video is relatively terrible. The first thing we want to talk about today is kind of an overview of high availability and how clusters fit into that, what they're used for. So let's start by diagramming really quick what really basic elements you'd need to get some IT infrastructure stood up just in like a small office if you're setting up. So you would need an internet connection first of all. So there's our internet cloud there. To connect to the internet, you would need a firewall. And because I don't want to get too technical with this, let's just assume firewall also acts as like a router for business. So we've got internet, we've got our firewall. That next step is you connect that with, let's make our little network rack here. You connect the firewall to a switch, and this is our network connection. And you probably have more than one switch because this isn't too small of a business. And then from the switch, there's you're going to have everything connected to your power supply. So that's a terrible graphic of a power supply, but it works. And then finally, you have your servers, and I'm talking specifically about physical servers. And obviously this would be connected to a switch. Okay, so really basic overview. Here are your components to getting a network stood up and ready. Now, if we're talking about high availability, our focus is to identify single points of failure and to make those redundant so that we can tolerate single points of failure in any location. So starting from the bottom and working way up, let's talk about what these are going to be. So a server, I've got a network connections to a switch, right? But if I lose a network port, a network card on the server, or a network port on the server, or if I lose a port on the switch, I want to make sure there's redundant connections, right? So let's do 2 network connections. Also, server will be connected to power, but you also want redundant power supplies on a physical server. In case you lose one, you want to have a second so you don't fail it. So redundant network connections, redundant power supplies. The switches are going to be connected to each other, but oftentimes you want double connections there as well, just in case. And then also, you either have, depending on the size of your business, a lot of small business I work with have a single connection to the firewall. You might have 2 firewalls or 2 routers and a redundant connection there. So redundancy in the network connections all the way through, redundancy in power, redundancy in your internet connections, and then the last piece is you might have your primary internet connection, but you might also have a secondary smaller pipe that you're connected to just in case you lose internet. Like I said, all of these elements could be expensive, but if you're looking for high availability and you're trying to eliminate areas where you might suffer a failure just by losing a single component, this is kind of the high availability setup you're going for. Obviously, you need to expand it. Now, failover clusters are building on this same concept of not wanting a single point of failure. The failover clusters, however, are focusing on one thing. In our diagram, we have one physical server. A failover cluster is going to take multiple servers and pair them together to eliminate these single components of failure. So a failover cluster would act as your second physical server, and then this would be paired together so you have a shared role. Now, this is the gist. This is the concept of failover, of what failover clusters are trying to achieve. And I got an opportunity to use my whiteboard, so I'm very happy about it. So knowing that this is the concept, the next step is looking at, okay, what are the requirements for building a failover cluster? Now, I've got 2 physical servers here. We're going to get into some of the prerequisites and requirements as far as hardware are concerned, but to illustrate more specifically just the failover clusters, there's a couple things that you need. Obviously, you need 2 servers because a failover cluster running one is it's not really useful as far as a component. But the other thing that you need is on top of the servers, you need shared storage. So I don't know what the graphic would be for storage, but we'll just say this: storage with a big label. And I hope this is readable. Eventually I'm going to get thicker markers, but these are the ones that I got for free to try out, so we'll try this out. So you've got your 2 servers, and both servers have to be connected to a shared storage. Now, this is a requirement for failover clusters because almost everything you do on the cluster requires it to write to storage somewhere. There are some exceptions to this, but generally for the things that you use failover clusters for the sake of the AZ-801, you're going to need shared storage. We're going to talk through kind of how we hack this to get this working in a lab, but this could be a SAN, it could be a NAS, iSCSI, fiber channel, however you want to connect it. Both servers need to have access to the storage, so in case one fails, all of the roles and everything running on that storage can still be controlled by the second server. Now, the failover itself the failover cluster itself is basically just a database that consists of settings for the clusters. The cluster objects are represented in Active Directory as its own thing, and this is also an important component to understand once we start talking about Quorum, because this cluster database has to live somewhere when we get to that concept. But this makes up the failover cluster portion of high availability, where we're taking 2 servers and their shared storage and making the functions on those servers, whether it be a file server, a Hyper-V host, or some other role that a Windows server can perform, and we're pairing them together to be highly available so that if either one of these servers fail, the other server can pick up that workload and run without interruptions to the user. This is the high availability component of what clusters are trying to achieve. So, with this being said, let's cut over and go into the portion of actually creating a cluster and see what this looks like first person. Alright, we've cut over here to our management server that I'm going to be using both to host the storage for the cluster and also to do most of the cluster configuration from. I'm going to pause before we get into that, and we'll talk a little bit about prerequisites. There are quite a few. I'm going to include a link in the description of the video below to the Microsoft documentation for prerequisites because it's going to be important for you guys to go over that and be aware of what they are, especially if you're going to be running these on physical servers. Now, I say that because the prerequisites for physical servers are really the ones that are important. You're going to need to pay attention to those before you even order your equipment and set it up, because if something is not right, if you have a physical component that does not work with failover clusters, you're going to run into issues. And for a lot of the things people use failover clusters for, I'm thinking specifically for like Hyper-V services, you're going to run that on a physical machine. You're not going to have virtual servers like we are doing from here. And oftentimes, failover clusters, depending on the roles, more likely you're going to be running them on physical servers versus virtual. Virtual ones would be more for if you're using them for kind of SQL high availability, which is a really common use case even in the large enterprise I'm at. That's probably the main and the only reason we use clusters for, is to do SQL load balancing, because it works as a good front end for that. However, reference the documentation for physical servers. For virtual servers, in a lab environment like this, the requirements are a lot simpler, so we're not really going to worry about them too much. I'm not going to go into detail because it'd make for a really boring video. But the main requirements are that you have permissions and connectivity. To simplify our lab environment here, I'm running everything on a single subnet. I don't really want to deal with a multi-subnet, and with Azure it's difficult enough as it is. And I don't really need to worry about connectivity because I already have an Active Directory domain, which leads into my second big requirement, and that's going to be your Active Directory. You need to have the right permissions, and you should have DNS working in Active Directory. So let's go look at the permissions that we need and get those configured up front. So, whoops, I'm jumping around with Windows here. There we go. So I'm going to open Active Directory. And the way I have it set up is I've got a separate OU just for servers. So here's my servers OU. It's got my 2 cluster nodes in it. It's got my management server that I'm connected to currently. You don't need to do what I'm doing before you create the cluster, because when you create it, assuming you have permissions, it will automatically get created. But we're going to pre-create what's called the CNO, or a cluster name object. This is a computer object in Active Directory that represents the cluster itself. So if you remember the diagram from previously, that little database thing, that's going to be your CNO essentially. That's your cluster name object. So I'm going to pre-create that. Now, as I'm doing this, I'm going to point out the fact that this is kind of one of the AD permissions that's listed as a prerequisite. You need to be able to create computers in your Active Directory, computer objects. You also should be able to modify permissions on an OU, because we're going to get to that in a second. So I'm going to create the cluster that I'm going to create is going to be called cluster. So I'm going to create the object, and I'm going to disable it. Now it's important that this is disabled, because when you're pre-creating a cluster, if the computer object that it's going to inherit is not disabled, it will fail in the creation step. So I'm going to create it and disable it right away. The next thing I'm going to do, and this is really the more important thing, is I'm going to make sure that that computer object has permissions in Active Directory to create computer objects and read all properties. Those are the 2 permissions that your cluster object needs rights to do in Active Directory. Now, going back to my AD management tutorial from early on, you can go back and look at those videos. I don't want to just delegate permissions directly to an OU. I always do everything through groups. So I'm going to create an RBAC group, meaning it's a role and permission group for the servers OU, and this is to create computer objects. I'm going to add the cluster object that I just created. So check the box for computers. Whoop. Spell things correctly. Check. Okay. And then I'm going to delegate those rights. So right click on the servers OU, delegate rights, hit next. I'm going to select the group that I just made. I only have one RBAC group in my environment, so I'm going to go ahead and just search that way. Next. Now, this is not a common task, so this won't be permissions you can just delegate from the checkbox here. We're going to go to create custom tasks, and then I'm going to choose this folder, existing full objects, and creation of new objects in this folder. Meaning, this group will have permissions to that OU and anything downstream of that OU. So it'll be able to create in any sub OUs as well. Hit next. And I do want to check the box for read all properties because, like I said, that's one of the required permissions, even though it probably already has it just through default AD permissions. But first thing I'm going to do is check this because I want to do creation of specific child object, and I'm going to check the box for create computer objects. And I only did this up here is because it makes this create computer objects permission a lot easier to find. Then I'm going to check general, check read all properties, and now I'm good to go. Next. So those are the two permissions we need. Create computer objects, read all properties. I have them specified. I have them added to that group that the computer objects is added to, and hit finish. Now, just to reiterate and remind you why you'd want to do this to a group and not a computer object, this means I only have to do this once, and any future clusters I create, if I need to grant them the same permissions to the same OU, I can just add them to that group rather than need to manually delegate, and I don't need to worry about tracking down individual object permissions everywhere in my AD. It's just best practice. Okay, so that's really our AD prerequisites right there. We've pre-created the CNO, the cluster name object, and I've already granted it the rights that it needs to create other objects in Active Directory. If you're wondering why it needs those permissions, we will get to that when we talk about actually setting up the roles that it's going to be creating. So I'm going to go ahead and minimize Active Directory here. Now, that's really it for permissions for at least this virtual lab. Like I said, if you're doing a physical server or another server, it might be worth reviewing the prerequisites down below. But the next thing we have to do is, going back to the diagram I made earlier, the cluster nodes need access to shared storage. They have to be able to access the same backend storage, and to emulate that, what we're going to be doing is using iSCSI running on this management server. I'm going to pre-create a bunch of disks and then create a target and then configure my cluster nodes to connect to that target so that the storage is available to both of them. So what I have here is a script. I am making the script available in a repo in GitHub, so I will link that down below as well. So you'll be able to just come in here, update these values for your lab environment, and then run this. But I'll just run from top to bottom what it's doing. I specify my domain name. This is getting the name of the server we're on currently, so I don't need to do anything here. I set my target name, which isn't really important, but it's worth setting. I'm going to specify the directory I want the virtual disk files to be created in, and then the names of the virtual disks themselves. Like I said, this isn't that important. I'm just making 3 disks that are going to be available to the cluster. Next, I'm going to specify the cluster nodes themselves. This is going to be the VMs that are going to be members of that failover cluster. I have 2 named class P1 and P2. And this is getting into the actual configuration of the iSCSI service itself. So this is going to go through that list of disks and create each one. This is going to configure the iSCSI server side, so this portion, or this server's configuration that I'm on right now, to make those disks available. And then I have a script here that loops through each of the servers we have listed, the cluster nodes, and then configures them to start the iSCSI service and then install the features I need, which are going to be failover clustering and file server, because I'm going to be creating a file server role in my cluster. And then last, it connects to the iSCSI targets that I created up here. I am not going to run this bottom section yet because I have to do some tweaking, so we'll get back and do that. But I am going to highlight all of this and run it, and then I'm going to fast forward the video a little bit because this is going to take a little bit to run as it's connecting to these servers and creating the disks. Alright, our script is now finished running. I did my little tweaks that I needed to and got everything working. Had to do a little bit of, I wanted to error check the script because I converted it a little bit before running this lab. Just to see how this presents from the computer, I'm going to pull up a remote desktop connection to my first cluster node server here, and let me just pull up disk management, and you should be able to see the disks. Now this is prompting me because I have a couple other Azure disks that I haven't initialized. That's intentional. I'm going to use that for another lab, so I cancel out of this. But you can see the disks that I created on the management server for them to connect to were just 10 gigabit disks. I didn't need much space because, I mean, I'm not actually going to use them. But you can see that our script has configured, initialized, and then formatted volumes for each disk. Now, this is only on the first server that I've listed in that script because you only need to connect and initialize it on one. As long as the second server is connected to those iSCSI targets, that'll be enough for when we stand up the cluster. So I can see here I've got my disks set. Let me minimize out of here. I've got this script. I'm going to go ahead and minimize this, and we should be ready now to set up our cluster. So with that being said, this is going to be really easy. I'm going to open admin tools, go to Failover Cluster Manager, which I already have installed, and just to point that out as well, I installed that role. This script, two of the things it also installs is the Failover Cluster role, which is also a requirement that has to be installed in the nodes that you're adding to the cluster. And I've installed the file server role as well, which is what we will configure as a role in the cluster once it's online. So these are prerequisites I've also set up. Alright, in my manager, from my management server, I'm going to right click and go to create cluster. Hit next. Find my node names here. And because they're named similar, I can just do this and get both of them. Hit OK. These are the two nodes that I'm adding that I'm going to be configuring as cluster members. Next, this screen is whether or not you want to run tests to validate your cluster. Now, Microsoft recommends doing yes. You'll also note here, if I choose no, it says I do not require support from Microsoft for this cluster and therefore do not want to run the validation tests, which implies if you want Microsoft to help you support this cluster, you should run tests. You should pass. Now I'm going to click next here. These tests don't take too long to run. Skip that first page, and here you can see you can choose to only run specific tests if you're concerned about a specific element, or you can run all tests. For the sake of this lab, I'm going to go ahead and run all of them. I'm going to hit next. It's giving me a confirmation screen and do another one, and you can see on this screen it runs through a whole list of tests for the nodes that you're going to be configuring as a cluster. This is going to take a little while. I'm going to pause the video and fast forward when this test is finished. Alright, our report is now finished, and if I want to, I can click this box and open the report. And now, of course, I'm going to have to go click through every Edge intro screen because I don't have a group policy disabling this in a lab because GPOs in a lab suck. But give me a second here. Thank you, Microsoft, for making Edge terrible to run the first time. Stupid. Okay, here you've got your validation report that we just ran on the failover clusters, and you can see all of my categories are showing green across the board. I even have a checkbox next to network, which I wasn't expecting, because typically what I've done in the past is I have had a single NIC on my VMs, and I get just by creating multiple NICs, this box is green. But I have multiple because I'm going to be creating another video about configuring NIC teaming, which is a recommendation and creation, so that'll be later. But anyways, here you can see every single report item that it checks, and if you want to, you can click down by category, which will bring you to the subcategories. You can click into individual one, and it'll tell you the sort of things that it's checked for in the report. I'm not going to get too far into this, doesn't matter. We see green, we're good to go. It might be normal for you if you're running this report to see a couple of yellow warning signs. Warnings won't stop you from creating the cluster. They're just to point out areas that Microsoft has identified where you might run into trouble. Typically, you might see them with system configuration if your servers have a different OS update configured, and you might see them with network if you have a single NIC connection. Otherwise, it should be green, and if not, it gives you some ideas of where to go to troubleshoot to make sure that your configuration is valid for clusters. But for our purposes here, I'm going to go ahead and click finish, and it continues the setup cluster wizard. So I'm going to set my cluster name. Now this is the CNO that I referenced earlier when we were setting this up in Active Directory. This is the cluster name object. This is actually whatever you specify for cluster name here is a computer object that it's going to be creating in Active Directory to represent this cluster and the CNO. And a reminder, we disabled the computer object that we pre-created because I wanted to inherit that. If I left it enabled, I would get an error here. So click Next. Here's my confirmation. And then this checkbox says Add all eligible storage to the cluster. If I leave this checked and I hit Next, it will find those 3 drives, the VHDs, iSCSI drives that we configured, and add those automatically. I'm going to uncheck it so we can do that after the fact. Click Next, and it's going to go ahead and do the creation process here. This will be pretty quick, so I'm going to go ahead and let the video run. I said that, and of course it's taking a little bit longer, so I'll cut out just to save you some time on YouTube. Alright, so this is taking a lot longer than I expected. I'm going to guess that this is because I configured those nodes with extra NICs, which is not something I've done in the past. Typically I delete that because Azure doesn't really like it. So I'm going to cancel this. I'm going to go remove those extra NICs from the servers, and then we'll loop back to get to the same spot before, and I'll rerun this and then cut the video back over to that. So yeah, I'll be back in 2 seconds. I'm back. I've removed the NICs for these servers, which I assumed was the issue. And if I go here, one of these, +1, only possible network node. Basically, these errors are talking about network failures, which is kind of what I was expecting, right? I said the one variable is different is that I'm trying to create this cluster while they have multiple NICs. I've deleted the NICs. I've cleaned all that up. I went to try and recreate the cluster and come to find out that it thinks that these servers are already a member of a cluster. So it half created it, left it in a broken state, and now I'm in a spot where it's very difficult to fix this. I don't really want to go through the troubleshooting steps of figuring out every single thing I have to go through and recreate to get this working. So what I'm actually going to do is I'm going to blow it away. But I thought it was worth showing. This is a demonstration of why I dislike clusters. Clusters are really, really difficult and tedious, and they really require everything to be exactly right to work. But I figured I'd show you this as a sample in the video only because it's happened again. I've probably recreated these clusters 15 times as I worked through various different issues I've run into, most of them related to Azure. Anyways, here's the error. What I'm going to do is I'm going to just delete these VMs completely. I'm going to see if it created any DNS records or anything in the domain and clean those up. And then I'm going to use Terraform to redeploy the VMs without those NICs. I'm going to redeploy recreate the storage connections to the iSCSI disks, and then I'm going to go back and recreate the cluster. So it's going to take me a few minutes here, but I'm just going to pick up the video in a couple seconds. I just thought it was kind of worth pausing and using this as a demonstration of why clusters are terrible and why I don't like to use them. So I will be back in just a second for you, and in probably about 30 minutes for me. Okay. The sun has gone down, time has passed in large quantities, but we have a cluster. Ready to go, stood up. On top of having to work, it was just a mess trying to get this back up and running. So we are ready, and let's explore our new cluster. Okay. Right from the main screen here, there's one thing I wanted to point out, and that is normally when you create a cluster, you're going to have the cluster name object right here and an IP address associated with it. Because this is in Azure, they don't do IP addresses, and that has to do with it's some Azure networking component that also is going to make our file server role really difficult to set up. But for all intents and purposes, if you were running this in Hyper-V or on a physical server, you have an IP address, and that IP address would be separate from the IP address of the 2 member servers, and it would be a floating IP that is used to direct traffic one way or the other. But let's go ahead and get into this. This is listing the core resources for that cluster that exists. Right now it's literally just the cluster objects. We haven't really added anything else. But let's click through a couple things. Roles is not going to show anything yet in it. This is where we're going to go to set up our file server role when we're ready. Nodes will list your two servers. It also lists the site that they're associated with, and it will list their status. So if we add additional servers to this, it would show up in this tab, and this is also where we can kind of manage the servers, either pause, resume, that sort of thing. And then storage is the last big component. I guess there is network as well, which will be your cluster network, which is just the subnets associated with it. But storage, like I said, all of your shared storage would be configured here. Now, if I remember way back in the beginning of the day, for you about 30 seconds ago, we unchecked the box to automatically add discovered storage to this cluster. So nothing is listed here. If we were to configure the storage after the cluster is already set up and ready to go, you would come in here and we click on Add Disk up in the top right here. I believe we can also just right click here and add disk, and this will automatically detect any storage that is eligible to be added to the cluster. Now these 3 disks, 10 gig capacity, represent the 3 disks that we stood up in the beginning with the script with a 10 gig capacity. Because we stood it up, we connected to it with the servers, we provisioned volumes on one of our servers. We can now go back and it is available here to be used. So let's go ahead and add all 3 disks. And you'll see it goes through each one, checks it, marks it online, and now these disks are available to be used. This is shared storage that we can specify as the back end of any role. We're going to set up a file server role here in a second, but before I do that, I wanted to take a look at one other important element of a cluster, and that is the quorum. Now, I'm going to put a link also down below for documentation on the quorum and how to decide whether one is needed or not. But essentially, consider a quorum to be a voting member of the cluster to help determine which nodes are online and taking ownership of the roles that the cluster is running. Now, that might sound like a whole bunch of gibberish for you right now. Maybe it'd be best actually to cut over really quick, and I'll kind of draw this out. Just another opportunity here to use my new whiteboard, so I'm going to take it. Cluster, by default, we set up a cluster. It's got 2 nodes, right? We've got 1 and 2. Now, 2 servers is really simple. Technically, you do need a quorum for this, but it's not as critical because there's only 2. But for the sake of example, let's assume that this is not just 2 servers, but it's actually a pair of servers on each side. So this might be for like a stretch cluster, which represents a whole bunch of nodes in one virtual network, a whole bunch of nodes in a second virtual network or a network object, and those clusters can be configured to move. Maybe they're running a Hyper-V cluster role, and they have VMs running that can move in between those 2 in separate physical networks. If those physical network connections, right, let's say that this is connected, right? If this connection were to break, and there's an equal number of servers on each side, and those servers can talk to each other, but they can't talk to the servers can talk to other servers in the network, but they can't talk to the other networks. So like these 2 servers can talk to each other, and these 2 servers can talk to each other. At that point, if they're the same number, how would they know who's supposed to own the role? These servers are going to think they should own it. These servers are going to think they should own it, but it's the same number on either side, so nobody has a majority. So in that case, this is where having a quorum comes into place and is extra important. Essentially, a quorum is an extra object that helps break the tie in the event of even distribution. And also, specifically in these cases where you have distributed traffic and you might have the same number on each side. In this case, our P2 network over here might have access to the quorum, and this one, well, they technically both should have access. But let's say the quorum is a member of this side. Now this side has a majority, and we know that all of the roles are going to fail over to this side. So all of your VMs that are running should be running on this. This is the part that's going to own the majority role. But because they're the same number, the quorum helps break the tie in the vote. And really, that's the most important thing to think about for the sake of a quorum, is think about instances where you have even number of servers on both sides. That's where a quorum is required, because it's supposed to break ties in lack of network communication scenarios. If you're running just 2 servers, really it's just a third member, right? The chances of those servers losing access to each other is pretty low, and it's basically impossible in our situation when we're running on the same subnet. But if one goes offline, you still have a voting member that says, yes, take over this role. So going back to our remote desktop here, let's go through this process of setting up the quorum. It's actually really, really simple. So the reason I stood up the storage after creating the cluster is if I just went ahead and checked the box to configure available storage, what it would do is automatically grab one of these disks, and it would configure the disk to be a cluster witness, which is that cluster role. But it didn't do that because I added it after the fact, which is actually what I wanted to do. So if I right click on the cluster itself, the actual cluster object, and I go to more actions, I can configure the custom quorum settings here. And if I open this, it's literally just a wizard where you go click through and pick the type of settings you want. Now, just to see the options, I'm going to say select the quorum witness. If you say use default, it'll just select it for you and configure it. That's the case where it'll probably just select one of those disks. The problem is it's going to grab the whole disk as a witness, and you can't use that disk for anything else like storage. So here are our options then of how we can configure this quorum. We can configure a disk witness, which is what I just talked about. It's literally taking that entire disk that's configured and using that as the witness object. And if you're thinking of what the witness object is, it's actually just like a floating copy of the database of all the failover cluster settings that exists where you configure it, and then that's what's used as the vote. In this case, the disk would be what it chooses, but the most common one that I've seen is actually a file share witness, where you have like a central file share hosted somewhere, and that file share has the database copy, and that acts as your witness. But more recently, and kind of the recommended way to do it, is actually going and configuring a cloud witness. Now, I have a storage account configured. I'm going to go ahead and do this. But a cloud witness is literally taking a storage account on Azure and configuring your witness database to be stored on that. You can have multiple different cloud witnesses stored on a single storage account, and they're only like a few kilobytes in size. So it's really small, and it's basically free. So you don't really have a reason not to do it unless you don't have an Azure subscription, because standing up an entire subscription just for a free storage account is pretty crazy. But why not, right? It's not costing you anything. To configure the cloud witness, this is all you have to do. So let me go over to Azure and copy some stuff. My storage account name is going to be dzab failover cluster witness, and the storage account key I can just copy from the portal and paste in here. And I'm using a regular storage endpoint, so I'll just change it there. Click next, and an error. Verify the storage account name, account type. And if it messes up like this, I have to go and start the whole thing over again. Usually this is a problem because I have copied something wrong. So cloud witness, that is my storage account name. This tripped me up last time I did it too, but it was because I was trying to copy the entire storage endpoint instead of the account. So let's try this one more time. Next, I wonder what advanced quorum options are. Interesting. So you can actually configure which nodes, which servers are allowed to vote in the witness. I'm going to go ahead and select that default. And then, yeah, so literally that's the advanced settings, is you can configure special voting rules for your servers. And that's it. Otherwise, you can have no voting servers, and the witness itself just determines where the cluster rules are. That's another interesting configuration. I've never actually read about any documentation that recommends that, but it's good to know that it's a setting that's available. Okay, we're going to do this one more time. Copy, paste, make sure there's no characters on either side. Yeah. Let's try a different account key. And for endpoints, I shouldn't need to do anything. And just to confirm, let me pull up here. I'll cluster cloud witness. Let's see what it says we need to put in for input here. Yep, 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 yep. More actions. Yep, we did that. Okay, we need our storage account name. Make this bigger so you can see it on screen here. We need the access key, which we can just copy and paste them in the screen. And then optional, you can enter the name of another existing server in endpoint server name field. Oh, okay. So that's if you're using a government cloud or an Azure China sovereign cloud, sovereign nation cloud. I can't remember what they call that. But we want to use a regular. Regular witness. So let's switch back over here. This should work. I'm not sure why it's not. Unless I just had a leading character. Okay. So of course this isn't working. I don't know what the problem is here. So we're just going to do a disk witness instead. It's a problem with doing labs live, I guess. Next, disk witness. Yep. I'm just going to choose disk 1 because this is what it would have been by default if I had let it do itself. And now this is disk witness in Quorum. So that's good to go. Okay, so that's how you set up the Quorum. I don't know why that storage account didn't work. It should work. I'm thinking it's probably something funny that I'm just not thinking about right now. Not really that big of a deal. It's literally the exact same thing. The only difference would be there would be an extra drive available to us for storage, but we're not really putting anything here anyway, so it's not really that big of a deal. The other option in file share was literally just you specify the path to a file share, and it will save it wherever you specify. It does bother me that didn't work, but I don't really care. Okay. So let's finish out this lab by going ahead and creating a role. Now, this roles tab is basically just like the add server roles or features menu on a regular server. The difference is you're installing it on a cluster, meaning the role itself is going to be load balanced between nodes in the cluster. The one thing to note before we do this is installing a role. This is why we needed those Active Directory permissions that we set up in the very beginning as a part of a prerequisite. Because when you create a role, it's not just installing the role on the server. Actually, the role needs to already be installed and available on the nodes. It's actually creating what's called, I think it's a VNO, a virtual name object. Essentially, it's an object. It's another computer in the Active Directory domain, a computer object that represents the role that you've then installed. So when I create this, it's going to go and create a computer object in Active Directory to represent this. Now, all I have to do is hit next, click on the role itself, hit next, and then I have a couple options for a different file server. I'm going to go with general use here. And then this client access point is going to be something that's a little bit unique. So here's where we'd actually name the object that's getting created. In this case, I'm going to call it files because it's really generic. Because Azure VMs are configured to use DHCP, even when they're statically assigned, it does some back-end DHCP reservation stuff. It doesn't give me the option to choose an IP address for this role. But I do need to choose an IP address. If I did it just like this, it would never work in Azure. I think something like, I read it in a really old document from like 2015, like a blog post, that if I were to configure this role instead from the owner node, of this role. So if I were to go to either the P1 or P2 server and then install this role from there, it would work. But I'm not going to do that. I'd rather it work up front. So I'm just going to use PowerShell to create this. I'm just clicking through the GUI so you can kind of see what it's like. But I'd specify the name. Normally you specify an IP address, and that IP address creates a DNS record that points to the Active Directory computer object, which then balances the role between the two nodes that is serving the role. So after that, I would then select my storage. I can just check both these boxes, and I'm given a really nice confirmation menu here. Now, the OU it's going to create in is another thing worth calling out. By default, all cluster roles or all cluster role objects are going to be created in the same OU as the cluster itself, which is why we had to grant that computer object the create computers permission in AD to that OU. And also, you'd normally create an IP address object as well in the cluster that represents the IP that we specified. But in this case, it's going to use a DHCP address, which means it's going to fail. So I'm actually going to cancel out of this, and then I'm going to switch over and use the PowerShell commands to create this instead, because if I use a PowerShell command, I can specify the static IP address that I want to use, and then that should make this work. So let me cut over back to PowerShell, and I need to go to another screen here and copy a script. Copy this, go new, paste. Alright, I've got my cluster name. This is the IP address that I'm going to use and assign to the failover or the file server role. I have another command here to get my cluster disks. Ironically, I don't think this is going to work from my management server here. So if I copy the name here and then I run this command, which is using get cluster resource, I think this fails if I don't run it from one of the nodes. It did not fail. Cool. So it did get my disks. Never mind. If I do just this, yeah, I get an error. Let's try with the cluster name. Hey, look, that works. Okay. Like I said, I've seen so many strange things since doing this lab, and I've redone it so many times I forget what I saw versus what I didn't. So forgive me if I'm a little all over the map. But we've got our disks, we've got the static IP address that we want to assign to the cluster, and last I'm going to use this command, add cluster file server role in our cluster using the disks that we got. I'm going to name it files, like we said, and then I'm going to give it that static address that I specified. Bam! Okay. Why is this null? Let me do that again. Check that. That's good. No. I must not have saved that one variable. That's weird. Okay. So it's going to go through and do this. And it shows our role is now created. It is online, meaning it's working. The owner node is assigned to the P2 server, and the name is files. So if I go open my console over here, I can now see I have my files role. The file server role is installed. Right now it's being hosted on the P2 server, meaning if someone were to try and access this file share, it's going to be connecting to P2. If that node fails, it'll switch over to P1 automatically. And remember, it's a cluster. The storage is shared, so it doesn't really matter which node is going through. That data is going to be the same regardless. Really, the point of the owner node for a file server is who has write access to that share. Everybody is always going to be maintaining read access. Now, just as last bit of demo, I'm going to pull up Active Directory and let's see the computer object. You see right here, it created us a files computer object to represent that role here, and it'll also have created, because we assigned it an IP address, connect to my DNS server here, it created us a DNS record for files with the IP 1.100. Now, if this was using Hyper-V, man, I would be able to open File Explorer right now, go to Files like this, and it would be able to connect. Now, I haven't configured any shares, but this is not going to work. The reason this is not going to work is because I'm running this on Azure, and Azure does not work out of the box doing this. You can't have that random IP address for the cluster object receive communication. It just doesn't work with Azure Virtual Networks. So the way I would have to set this up to get this to work is I would need to configure an internal load balancer in Azure that has a front end IP address of the 1.100 IP that represents the cluster IP address right here, that 10.0.1.100. So I'd have to create a load balancer at that address, and then on the back end of that load balancer I'd have to point to my two cluster nodes, and then I'd have to configure it to do pass through something. I can't remember the exact term. And then I would need to configure a heartbeat monitor on the cluster port, which is 59.999. And then I have to come in here and run PowerShell commands to make sure the cluster resource was configured to receive traffic for that heartbeat monitor on that port, on that IP address that's passed through to the backend nodes. That's a lot of work. I'm going to do that, but I'm not going to go through that in the demo for this video because it's not really important for you to know. If you're really interested in it, I will include that link as well in the description if you want to do the blog post, but I don't know why you would ever want to run a file cluster in Azure on VMs outside of a lab environment. So I'm going to set that up and then cut back here and we'll demo this from the VM. Okay, I am back and we are now working. So I went through the crazy backend process of setting up the internal load balancer in Azure, configuring the IP to match the cluster, configuring some additional parameters that I needed on the server side to map the health probe to the right port. Ignore that, I was doing refresh, but everything's working. And now if I open, well, let's first show I've got my file roll running. It's running on P1, and if I open File Explorer and I do backslash files, it takes me to my files directory, meaning this is working. But let's take a step further and create ourselves a share. So I've got the resources that are mapped and connected to this role down here at the bottom. You can see the two disks that it's using, the file server role itself. So this is the virtual computer object, the VCO, and then the server name, right? Let's go here and you can see kind of the file path there, but let's go ahead and create a new share. Now, if I remember correctly, this is another thing that I cannot do from the console. I need to do from the servers that's hosting the role. I believe that was an Azure requirement. Yeah. See, it's not ready to be share creation. So that might be a separate port that it's trying to use that's just not allowed through the ILB. But let's go ahead and do this the manual way. So I'm going to go here. I'm going to go to files and I'm going to actually not do that. I'm going to go here. This is my P1 server, right? So this is the owner node of the role. And that is why if I go to my Windows desktop here, I can see the disks available for it. Now the cluster disks are G and H. The F disk is my cluster witness. So I'm going to go ahead and go to G and I'm going to create a new folder. We'll call this share, very descriptive. And I'm going to go ahead and share this. Give everyone right access to the share. Actually, sorry. This is the share permission, so do full control here. And then my NTFS permission. Going to do modify. So read write access to the share to domain users. Alright. And now that that's configured, if I minimize this, I should see, yep, I see the share pop up right there as being available in the role. Like I said, there's a problem with the client access point in running this in Azure. In a traditional failover cluster, you can do this from the console and it's going to work just fine. But Azure VMs, Azure and clusters don't get along. If I haven't said it enough yet, then I'll just say it again. So now if I go here, I can see my shared drive, and let me create a new text document. create this, add some text and save it. And now this exists in my clustered share. It's running on P1, and that's what I named the text document for. And just because I'm curious, I don't actually know the answer to this. I'm curious if I look at the drives in this server, if I can actually see the clustered storage. No, I can't. Which is kind of what I was expecting, right? Because the owner of those roles should see this drives. But let's go ahead and fail over our file server to the other node. So just to walk through how I did that really quick. Right click, move, because we're moving the role. I can either do the best possible node, which is there's a couple of factors it'll take into consideration to choose that. We only have one other node. I'm just going to select the node, choose P2, hit OK. And it'll say the move did not complete. I'm kind of glad it did this because it gives us one other thing to look at to demo here for the lab. If I click on information details, it will tell me cluster storage is not connected to the node. So something that I was having to do earlier, I still have firewalls enabled on these lab VMs because the default out of the box stuff, and that firewall has been messing with my storage connection. So I'm going to rerun this script block that's supposed to start this iSCSI service and reconnect to the target. So if I rerun this, it's going to fail on the one server. It's already connected. I did restart these servers as part of the load balancer configuration, which is probably why it lost connection. But let's go back here now that I've done that. Do I see the drives? No, I don't see the drives, but it should be connected now. And if I go back in over here and remove this to P2 and hit OK. Boop, boop, boop. Pending. And we are moved. Yeah, like I said, there are definitely some firewall considerations that you'll want to take into consideration for clusters. And in this case, because I'm just spinning up these VMs and creating things on them, it still has the default firewall rules applied. And for whatever reason, when I restart a server, it's not able to reinitiate the iSCSI connection. However, if I manually run the PowerShell commands to do that, it works just fine. So just something goofy with VMs and firewalls. I ended up just turning the firewall off on my P1 and P2 node for the health probe on the load balancer, which is what's determining whether the backend servers are online or not. But regardless, the node is now moved. So if I go back to P2, I can see my cluster disks G and H that we're using for that file server, G and H down here, are now showing up on my P2 server. They've moved over because the role failed over, and those disks are associated with the failover cluster role. And if I navigate back to the share, actually I don't need to navigate. If I just refresh this and I say modify, save. Now, one, I was able to access it. Two, I can update it and save it. And if I go back to P2 and open this drive and the share and the file, bam, the text I added is there. So that is, in a nutshell, the failover cluster role and how to get it set up and how to get it configured. So we've ran through a whole bunch of things in this video. We ran through kind of the intro to clusters and what their purpose is. We did we went over some of the prerequisites to clusters. Specifically in our lab here, we went through the Active Directory prerequisites. One thing I don't think I mentioned for the AD things is when you're creating the cluster, you do need permissions to create the computer object yourself in the OU. So if your domain does not allow that, or if you're running from a less privileged account, you might not be able to create the cluster object in AD, which will prevent it from being created. I'm running this lab as a DA account, so it didn't have those permissions. But we did the extra step of making sure the CNO, the cluster named object, does have rights in Active Directory to create other computer objects. And then when we came later and set up the role, you saw that created a computer object in the same OU called files because it had rights to do it. We also went through the shared storage configuration requirement. In this case, we stood up an iSCSI connection. Like I said, that's going to be linked down below. And we talked about the nodes. And what else did we do? We got our file server role itself set up. Oh, and then we reviewed the cluster quorum and got a little mad because the cloud disk witness didn't work for some reason that I'm not going to research right now. And instead we set up a disk witness instead of the cloud storage account one. So this is the basic overview of creating clusters. If you have any questions, feel free to leave me comments down below, and I will do my best to respond to those. Wow, for a second there I thought I had lost my RDP connection and recorded a video. That was a waste. The next video that I am probably going to be covering here is probably going to be some more advanced cluster settings. So that's going to be things like setting up your HA configuration and getting into storage spaces direct, which is using direct local storage on the server nodes to create a storage pool. And then we're going to get into some cluster maintenance. So controlling failover between nodes, how to do cluster updating, stuff like that. So it's going to be kind of some more advanced HA configurations, and then some day 2 operations on managing a cluster. So look for that video to be up next.